Hey everyone, welcome back. Today we're going to look at exponent laws. If you've completed the previous videos, Intro to Exponents, and the Grade 8 fraction videos, today's lesson will be a lot easier for you. So we're going to use the definition of exponents to come up with some exponent laws. So let's go ahead and start. 3 squared times 3 to the 4 gives 3 like that, which is 3 to the 6. And so we notice 3 squared times 3 to the 4 is 3 to the 2 plus 4, which is 3 to the 6, like that. So that gives our first rule, called the product rule. So if a is a real number, such that a is non-zero, and m and n be integers, then a to the m times a to the n equals a to the m plus n, like that. So let's do some examples. Example 1, we're going to simplify twice. Once using the definition of exponents, and the other time using the product rule. So we'll see the difference. So 5 squared, 5 cubed, 5, like that. And so there's 5 of them, so 5 to the 5, like that. Or we can do 5 to the 2 plus 3, which gives 5 to the 5. B, 2 to the 1 times 2 to the 4. So 2 is there, 2 to the 4 is 1, 2, 3, 4, like that, and there's a total of 5, so 2 to the 5. Or we can go 2 to the 1 plus 4, which gives 2 to the 5. C, 7 cubed times 7 to the 5, so 7 to the 3, 1, 2, 3, 7 to the 5, 1, 2, 3, 4, 5. There's 8 of them, so this is 7 to the 8, like that. Or we can go 7 to the 3 plus 5, which gives 8, like that. So practice number 1. Simplify twice, once using the definition of exponents, and the other using the product rule. Go ahead and pause the video and do that. Okay, we're back. So we have 6 to the 3 times 6 to the 4. So 6 to the 3, 1, 2, 3. 6 to the 4, 1, 2, 3, 4. Total of 7. By definition, this is 6 to the 7. Or we could go 6 to the 3 plus 4, which gives 6 to the 7. B, 9 to the 2 times 9 to the 5. So 1, 2 for the first one. 1, 2, 3, 4, 5 for the second one. And this by definition is 9 to the 7. Or we can go 9 to the 2 plus 5, which gives 9 to the 7, like that. Okay, let's notice something else. 2 to the 5 over 2 to the 2. 2 to the 5 is 1, 2, 3, 4, 5, like that. 2 to the square is 1, 2, like that. We know from our fraction videos that we can cancel because it's multiplication. So bang, 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 bang. What's left is 3 2's. So this, by definition, is 2 to the 3, like that. And so we notice that 2 to the 5 over 2 to the 2 is the same as going 2 to the 5 minus 2, which gives 2 to the 3. And so this gives birth to our quotient rule. Let a be a real number such that a is non-zero, and let m and n be integers. Then a to the m over a to the n is a to the m minus n, like that. So let's do some examples. Example 2, we're going to simplify twice. Once using the definition of exponents, and the other using the quotient rule. So let's write out the definition. 5 to the 5, 1, 2, 3, 4, 5. 5 to the 3, 1, 2, 3, like that. These cancel out. What's left is 2 5's on the top, which by definition is 5 squared. Or we can use 5 to the 5 minus 3, like that, which gives 5 squared. B, 7 to the 4 over 7 to the 1. So 7 to the 4, 1, 2, 3, 4, like that. 7 to the 1 is there. Cancel out one of the 7's. What's left is 7 to the 3. Or we can go 7 to the 4 minus 1, which gives 7 to the 3. C, 6 to the 12 over 6 to the 5. Bang, 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 12 times like that. And then 5 on the bottom. And so these 5 on the bottom cancel out with these 5 here. What's left is 7 6's. So this is 6 to the 7 by definition. Or we can go 6 to the 12 minus 5, which gives 6 to the 7. So practice number 2. I'm going to ask for you to simplify twice. Once using the definition of exponents, the other using the quotient rule. Go go ahead and pause the video and do that. Oh, this is a 12 to the 3 if you have trouble reading that. Okay, so 5 to the 10, bang, 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 like that. 5 to the 3, 5, 5, 5. So this cancels out top and bottom. What's left is 7 of them, which is, by definition, 5 to the 7. B, 12 to the 5, so 1, 2, 3, 4, 5. 12 to the 3, 1, 2, 3. 3 of them cancel out, top and bottom. What's left is 2, so 12 to the 2, like that. Or we can go 12 to the 5 minus 3, which is 12 squared, like that. Okay. Practice number 3. Simplify. Go ahead and pause the video and simplify. Okay, we're back. So what do we have? Here we have, we can add them up. So 6 to the 3 plus 2 plus 5. So 6 to the 10 over 6 to the 4. And then we use our quotient rule, 6 to the 10 minus 4. So 6 to the 6 is our final answer. B, 7 to the 10 over 7 to the 4, 7 to the 3. This becomes 7 to the 7. And we're going to use quotient rule here, 7 to the 10 minus 7, which gives 7 to the 3. C, 4 to the 0 is 1. 4 to the 5 is there. 2 squared is 4. 4 to the 5 times 1 is 4 to the 5. 4 to the 5 over 4 to the 1 is 4 to the 5 minus 1, which is 4 to the 4. D, negative 5 squared is 25. 3 squared is 9. All of that over 3. It's not a multiplication, so we can't cancel anything. And so this is 34 over 3 as our final answer. Okay, let's go notice some more stuff. 3 squared cubed. What this means is 3 squared is 3 times, like that, because it's cubed. And then each of these 3 squares is 3, 3. And so there are 6 3's like that, so that's 3 to the 6. So we notice 3 squared to the 3 is 3 to the 6. And this is 2 times 3, which gives 6, like that. And so that gives us our power rule. Let a be a real number and m and n be integers. Then a to the m, all of that to the n, is a to the m times n, like that. Okay, example 3. Simplify twice. Once using the definition of exponents, the other using the power rule. So 7 to the 4 to the 2 means 7 to the 4 times 7 to the 4. Each of these 7's happen 4 times like that, and so this gives 7 to the 8. Or we can go 7 to the 4 times 2, which gives 7 to the 8, like that. B, 6 cubed to the 3, like that. So this 6 to the 3 is happening 3 times. Each 6 to the 3 is 666, like that, and so we have 6 to the 9. Or we can go 6 to the 3 times 3, which gives 6 to the 9, like that. C, 4 squared to the 5. So 4 squared is happening 5 times. Each of the 4 squared is 4 times 4. And so this gives us a total of 4 to the 10, like that. Or we can go 4 to the 2 times 5, which gives 4 to the 10. So practice number 4. I'm asking you to go ahead and simplify twice. Once using the definition of exponents, and the other using the power rule. There we go. So go ahead and pause the video and answer that. Okay, we're back. So 3 cubed to the 4. This is 3 cubed happening 4 times. Each of the 3 to the 3 is 3, 3, 3. So this gives a total of 3 to the 12, like that. Or we can go 3 to the 3 times 4, which gives 12, like that. B, 5 squared to the 3. So 5 squared is happening 3 times. 5 squared is 5 times 5. So this is all 5 to the 6, like that. Or we can go 5 to the 2 times 3, which gives 5 to the 6. And C, 7 to the 4 squared, like that. So we have 7 to the 4 times 7 to the 4. And this is 7 to the 8. So 7 to the 4 times 2 is 7 to the 8, like that. Okay, let's notice some more stuff. 4 times 5 to the 3. This means 4 times 5 times 4 times 5 times 4 times 5. That's what this means. We can rearrange it so we have 4, 4, 4, 5, 5, 5 like that. And so this is 4 cubed times 5 cubed like that. So we notice that this 3 kind of distributes to both, and so this becomes 4 cubed times 5 cubed like that. And I want to comment, it has to be a multiplication. If it's an addition, this is what happens. This is 9 cubed, which is 729 like that. And this is not the same as 4 cubed plus 5 cubed, right? We're not distributing it because there's a plus there. If we did, we would get 189, which is not true. It's not the right answer. So it must be a multiplication when we kind of distribute our 3 like that. Okay, and so what we have then is a product raised to a power. Right, so we have a and b real numbers and n an integer. So we have a times b to the n gives a to the n times b to the n, like that. So example 4, write in exponential form without the parentheses. So here we have 2 cubed times 7 cubed, like that. This is a to the 7 times c to the 7. 4 plus 3 gives 7, so we have 7 to the 5 like that. 3 cubed times a cubed like that. 2 squared plus 3 squared, all of that squared, so this gives 4 plus 9. It's an addition, so we do 13 squared, and that's our final answer. Okay, time for some practice. Practice number 5. Write in exponential form without the parentheses. Go ahead and pause the video and answer that. Okay, we're back. So this gives c cubed d cubed like that. 2 to the 4 times a to the 4. 3 to the 5 times d to the 5. 7 to the 3 like that. A plus a is 2a, and then we get 2 to the 4, a to the 4 like that. 3d plus 5d gives 8d, right? 3 apples plus 5 apples is 8 apples, like that. And then so this is 8 to the 7 times d to the 7, like that. Okay, our last little notice here. 4 over 5 cubed. This is 4 over 5, 4 over 5, 4 over 5, like that. Multiply the top is 4 to the 3. Multiply the bottom is 5 to the 3, like that. So we notice that 4 over 5 cubed, we kind of distribute the 3 like this. 4 cubed over 5 cubed, like that. And so this is a quotient raised to a power. So we have a and b be real numbers such that b is non-zero, n be an integer. A over b to the n kind of distributes here, and so we have a to the n over b to the n, like that. So example number 5, write in exponential form without parentheses. So this is c4 over d4, 2,7 over a7, 4,8 over 5 to the 8, d, 2a over 3c, all of that cubed, so the 3 goes to the top, and the 3 goes to the bottom. And then now we distribute again. 2a cubed is 2 cubed a cubed. 3c cubed is 3 cubed c cubed, like that. 1 plus 5 over 7 plus 2. This gives 6 over 9, reduces to 2 over 3. So we have 2 to the 4 over 3 to the 4, like that. Okay, so practice number 6. Write in exponential form without parentheses. Go ahead and pause the video and answer that. Okay, so this is 5 to the 6 over a to the 6. B, c to the 20 over d to the 20, like that. And last couple problems. Same question. Go ahead and pause the video and answer that. Okay, so we have 4a squared over b squared, and this becomes 4 squared a squared over b squared, like that. D, 21 over 100, this becomes 21 cubed over 100 cubed. E cubed over f to the 4, distribute the n like that. So we have e cubed to the n, f4 to the n, multiply the exponents. So this is e3n over f to the 4n like that. And that's it. It's that easy. I'll see you guys in the next lesson.